Hey everybody, it's Mr. Carr again. Today we're looking at 1.7 day 2, and we're going to continue with our inverse relations and functions right now. Okay, so the biggest thing about today is how do we confirm, if we're given two functions, that we do indeed have inverse functions with each other. So the key is this: if you were to do composite functions where you take your g of x function inside of f, so f of g of x, then so the definition here says that for every x in the domain of g of x, and if we have g of f of x, it's going to come out to x. Sorry, I'm saying that awkwardly. Let's say it this way. If you take the composite function and you take g of x, put it inside of f, and you also take f of x, put it inside g, they should end up with the same exact thing at the end. It just comes out to x. Okay, so algebraically, that's what we're going to do. We're going to test that out. If we can take a function, put it inside one, take that for other function, put it back in the other one, they both come out to the same thing of x. Okay, so let's test that right here. We want to show that 2/3 x plus 2 and 3/2 times x minus 2 are inverse functions. So first thing I'm going to do is I'm going to do f of g of x here. So that means I'm going to take this function and plug it in right here. So I'm going to have 2/3 multiplied by 3/2 times x minus 2, and then plus 2 at the end. Okay, now because it's all multiplication here, here, and here, I can actually just choose to do this first. 2/3 times 3/2 will actually cancel each other out. So f of g of x is equal to x minus 2 and then plus 2. So the negative 2 and positive 2 will cancel each other out as well. So I end up with just x. One side is not enough. I also have to do the g of f of x. So that's going to look like this. So g of f of x, I'm going to be taking this whole function and putting it into that input. Okay, so there'll be 3/2 parentheses. I'm going to do another set of parentheses. 2/3 x plus 2 minus 2, and then other parentheses here. Okay, so when I look at this one, I can combine my like terms here and here. So that g of f of x, I'll have 3/2 times, it'll be 2/3 x and just 2/3 x, because these will just cancel each other out. From here, I got 3/2 times 2/3, so those actually cancel each other out as well. So I end up with g of f of x is equal to x. So all that work, because they both came out to x, is yes, they are inverses. Okay, so that's what we just confirmed algebraically there. Find inverse functions graphically. So use the graph of f of x equals x to the third minus 2 to sketch the graph of its inverse. So remembering from what my parent functions look like, I'm going to cross here at -2. I'm going to have a point here, and then it's going to go 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is what my x to the third minus 2 function looks like. So to help me with this, I'm going to go ahead and plot y equals x. Okay, the thing to remember about this is my inverse function is always going to move something like this. I'm gonna, if I take this point, for example, I go 1, 2, 3, 4 this way, 2, 3, 4 this way. Okay, that's to me an easy way to find out where's this across from each other. Like these two distances here and here are the same. The easiest way to do it is I just go 4 and 4. So I'm going to do that for any points that I know. So for example, I've got this point here. Oops, go back to the pen. This point here, you can go 1, 2 up here. I'm going to go 1, 2 over here. This point is also going to go 1, 2. So I'm going to go 1, 2. This one's going to go 1, 2, and then 1, 2 again. But down here, I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It's a little bit tough to see on the side, but here's my points connected. There. So that's my sketch of the inverse. Now to find the actual inverse function, I'm going to go ahead and just do my algebraic process from before. So I'm going to swap out. I'm going to make it x equals y to the third minus 2. Okay. I'm going to add 2 to both sides. So I get x plus 2 is equal to y to the third. Then I'm going to undo the cube. So by taking the cube root of both sides. So the cube root of x plus 2 is equal to my new y here. Because it's an inverse function, I'm going to say f to the negative 1 of x equals the cube root of x plus 2. You can kind of see how that works on there. This is a cube root function like this. And let's go back to green. It is a cube root function. It is plus 2, so it's moving to the left from the origin there. Okay. So yeah, graphically and algebraically, we can see how that works on there. All right, use the inverse function here. The fixed cost for manufacturing one type of stereo system is $96,000 with a variable cost of $80 per unit. Write a function representing the total cost of making X stereos. So my function here is going to be defined by 96,000 for the fixed cost plus 80 times the variable cost. Okay. Now I want to find the inverse of that function. So I'm going to swap it out. I'm going to make it X equals 96,000 plus 80y. Subtract the 96,000 over. That's equal to 80y, and then I divide by 80. So I'm going to just write it over here. The inverse function of x is going to be equal to x minus 96,000 over 80. Now, how does that help us? It's one that you're not going to necessarily use a lot, but we can actually use the original function, now work it backwards. If I given a cost, figure out how many units are worth. That's one of the nice little features with our inverses, that we can kind of go back and forth in terms of our inputs and outputs now. So find the number of stereos made if the total cost was 216,000. Well, that's what my inverse function is representing. Okay, it is the this is the inverse of this is representing the number. My output is going to be number of stereos with a cost of 216,000. Okay. So that's what we're going to do here. So I'll pull out my calculator. So I got 216,000 minus the 96,000, and that comes out to 120,000. Okay, I can divide that by 80. So my inverse value here, technically I should be doing inverse of 216,000. There's my input, comes out to 1,500. So the answer is it's 1,500 stereos. Okay. So again, when it was written this way, my input was number of stereos, my output was cost. When it's written as the inverse, well, now the inverse is going to be my number of stereos, and then my input's going to be cost. So they're just backwards of each other in terms of their variables. Okay, and that is it for today. So don't forget, when we confirm that functions are inverses of each other, we're doing composite functions to make sure that they come out to the same value of x. That's their outputs either way. We can graph them and understand that it's reflecting on the line y equals x. So that's how we can find just a graph of our inverse function easily without having to calculate it out. And also just putting it into terms of our word problems and understanding that the inverses, like we base our swapping inputs and outputs. So whatever your input was at the beginning is now your output in the end. Okay, that's it for today. Take care, everybody.